Hello, crazy math nerds. It's the crazy math nerd back again for, let's see, this is the third installment of the discussion on derivatives. So we always like to go back a little bit and see what we've already done. To let you know, I am on Master Math Mentor, page 36. So if I can get me a little pointer. See right there? So fun. I can move it around. Can I twirl it? I don't know. It's a new little thing for me. And he goes through and talks to you about the rules that we kind of already know, in that the derivative of a constant is a constant, right there. And also, I'm going to change this. I'm going to have my fun little pointer. And the derivative, oh, look at that, little laser right there. The derivative, excuse me, of y equals x is 1. And remember we talked about that that whole use of d dx and the function, and that's a way to ask the question and tell you the function all at one time, and he's using that notation, so that showed up a lot here. Wow, look at that. And they do use that a lot in definitions. Yay, the power rule. It gives us the power to take derivatives of easy polynomials. And of course we know that's take that n down, right, and subtract that 1 from n. All right, let's go and look at the other thing he said. Now, so we've gotten the power rule and gotten the constant rule, and so now we're going to talk about what you can and can't do with things that are done to functions. For example, this function is multiplied by a constant. And so to find the derivative, you just leave the constant there and write the derivative. Very similar to like if you had 2x cubed, and that was y, and you're doing y prime, then that would be, you take that down and multiply it. It just becomes part of the whole derivative. And you could say 2 times 3x squared, right, that derivative, and it would end up being there. So if you have a constant, not a big deal. Also, let me make this a little bigger so you can see this, maybe. I'm using a new little thing on my iPad, so if I get a little squirrely, just forgive me. We'll get there. There we go. All right. Also, if you add two functions together, you can simply write their derivatives as the sum of each individual derivative, and we've been doing that with polynomials, and the same thing with subtraction. Okay, not a big deal. You just take the derivative of either one and add them or subtract them. If you have a constant, not a problem. When we are going to have a problem is when we have things multiplied or divided. So if you have a product of two functions, then if I took that product and put it into the limit definition of the derivative and went through all my expansions and all my canceling and the factoring and all of that, it would fit this following pattern that you see here. It would fit that pattern. And notice that it's, a lot of people think, well, okay, so if you have f of x times g of x, well, let me just take, and I write d dx, look at there. Then I'm just going to say the derivative of x times the derivative of g. That is not true. No, 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 no. That does not equal that. It only works, I'm going to write derivative. That does not equal that. It only works if you're adding or subtracting functions. If you took two functions and took it through that limit definition like we did before, it would not follow this pattern. It would follow the pattern defined in something called the product rule. Well, why do we call it the product rule? Because when you multiply two functions together, the answer to that is called a product. And so if you have a product, two things multiplied together, you have to use the product pattern in order to find the derivative. Okay? So I want to show you something that I consider kind of fun, and it's how it's, Kitty always has her kittyisms. So when I look at this, I think of this as the first function and this as the second function, because that's the first one times the second one. And so when I look at this pattern of the product rule, the pattern is the first function times the derivative of the second function. And that's supposed to be a d. Let me try that again. That's supposed to be a d. There we go. So 1 times, and I don't say the times, I just say, I'm having a hard time writing today, sorry. So it's 1d2, and that means they're multiplied, derivative of the second, see d2, plus the second times the derivative of the first. So if I actually were to take two functions that were multiplied together and put them in the definition of the derivative and did all that stuff, that is what I would end up with, this pattern, okay? And so after they did that, a lot of times they found the pattern and showed us so we wouldn't have to go through that. That'd be really hard to do. So let's do part A of this product rule. So it told us to find y prime, and notice that this function is multiplied by that function. Could we distribute and then get a polynomial and multiply it? Yes, we could, but we want to just practice this so you can see what it looks like. So when it says f of x, that really means write down the very first function. That's what that means. Or when you see 1d2, that means, just write down 4x minus 2x squared. You're just writing it down, okay? All right, so there's 1. d2 means to take the derivative of the second function. So there's the second guy, g of x, and that says g prime. So take the derivative of just that second guy. There's 1 and 2, right? And that's going to be 3, because the derivative of 3x is 3, and the derivative of 5 is 0. And then it says we have to add. The pattern is 1d2 plus the second function. That means write it down. Don't do anything to it. And then take the derivative of the first function, because that's what f prime means, the derivative of the first function, and that is 4 minus 4x. And that's from all our power rule stuff that we learned yesterday. Okay? And for now, let me do this so you don't think that goes with it. For now, I'm just going to leave that alone. Eventually, we will have to combine things and factor things out and all of that. But for today, we just want to introduce it. So this is kind of where we are. All right. So let's look at C and do it. All right. So it says to find f prime of x. That means the slope of the tangent line, the instantaneous rate of change, the slope of the curve, the derivative. We want to differentiate this. Isn't that crazy? All right, so this is 1 and this is 2. So I'm going to follow the pattern. And you're going to have a fun way to remember this pattern. And so 1d2 plus 2d1 is my fun way to remember it. You can do whatever you want to. First derivative of the second plus second derivative of the first. I don't know. Everybody has a different way to do it. So here I go. So 1, or the first function, means write it down. Do not do anything to it. This is the pattern of what would happen if we made it go through all that limiting process. Now, take the derivative of the second, right there. So 1d2, derivative of the second, right there, right? So d2 is negative 20x cubed, just doing the power rule from yesterday, plus 6x squared minus 14x plus 1. Just doing bring down the power, subtract a power, bring down the power, subtract a power. And because I'm just kind of running out of room, I'm going to put my plus there and do, that's 1. I'm going to do this in a different color. That is 1, and this is D2. And now I'm going to do 2D1. And D, when I say D, I mean derivative of. And so now the second function, I'm just going to write it down. I know, right? Just write down the function just like you see it. And then I got to make a little correction on where I put D1, right? Because that's not right. Now there's D1. And then I'm going to write the derivative of the first piece, which is by the power rule. 6, 2 times 3 is 6, take away a power. Derivative of 2x is just 2, derivative of 5 is 0, we're not going to write that. So that is the product rule. So, I'm going to say this again. If you have a constant, that means a number. Just a number times a function. Not a problem. If you have pieces of functions added together that are 2 powers, not a problem. But if they're multiplied, they fit a different type of pattern, and that pattern is called the product rule. Oh, and let me show you this in symbols. I just want you to see this. So it says the product rule is applied when 2 functions of x are multiplied together. And the reason I say that, I've had people, let's say I had, I'll show you an example of what that doesn't look like. Let's say I had 2x squared, or 2x to the 6th. Oops, that was terrible. Some people might say, well, Miss Morgan, that 2 is multiplied by that x to the 6th. Really, that's when you're in a constant situation where you have a constant times the x to the 6th. So you're just going to go, okay, that's 12x to the 5th. That's that situation. But if you have a function of x and a function of x, like we just saw, there were x's in both of them, then you must do, I'm going to erase this so I can get this out of my way, because I need that room. Okay, I'm going to show you symbolically because this is going to end up being a big deal. I know you just saw it, but we're going to see it again. So we've got 1 d2 first derivative of the second plus, product is plus, 2, I don't know why I did that, that was silly, 2, then d1, derivative of the first. 1d2 plus 2d1, or first derivative of the second plus second derivative of the first. Okay, so now we've talked about adding and subtracting and multiplying by constants. Not a big deal. When we came to multiplication, we had a different pattern. So now what happens when you divide two functions of x? Again, we're going to have a problem. It doesn't fit the normal pattern. Of course, multiplication and division would not. I mean, think about putting that into the definition of the derivative, and you have a f of x plus h, and that's like x plus h squared times x plus h cubed. That is not going to be easy to do, right? I mean, it's just not. So it makes sense to me that we'd have a little bit more intricate patterns. All right, so the pattern for this one has, I'd like to highlight some things for you. Hold on just a minute. And so it has, now notice that there's a function on top and there's a function on the bottom. Okay, there we go. There's a function on top. I'm trying to highlight this, and there's a function on the bottom. We call the function on the top the high function because he's up top. So that's what we call him that. And we call, you're not going to believe this, the function on the bottom is low. So the guy on the top is high and the guy on the bottom is low. So we have a cute little saying for this. So I start with g of x, who's called low. So low, and you know how I always say d for something, a derivative of something. So low, d high, minus high, d low. So anytime I say d, I mean derivative of, over low squared. And so I had a child who made up a little kind of rhyme to this, and it's kind of like to the Cool Whip song. I don't know, but it's not mine, it's his, it's very cute. So he said, low d high minus high d low over low low. We'll do that again, ready? Low d high minus high d low over low low. So that's kind of what he did. I know, crazy, right? Let's see if I can get my pointer. If I can move it. There we go. Will it move with me? Yep. Low d high minus high d low over low low. Like the Cool Whip song. So that's kind of what he did, and that's the cute way to remember the quotient rule. Low being the function on the bottom, high being the function on the top, and d standing for derivative of. So notice that g of x is on the bottom, low. F of x is on the top, this means derivative, d high. F of x is on the top, that would be high, and g of x is on the bottom, derivative of it, d low, over the low function squared. So that's just a cute, and that's the pattern that's formed. I can't help it, that's just the way it is, and it is the pattern. I don't want to erase that. It won't let me erase it. Okay, so here we go. I'm going to show you how to do that. Are we ready? Ready! Here we go. So low means write the low function down. So I'm going to cheat a little bit. I'm going to write high and low. Okay? So the derivative is, because this says dy dx, so I can say equals low, d high. D high means the derivative of the top function, which is 5, minus. All right, I want you to notice something. In the product rule that we just did, product is plus, quotient is minus. And to me, that kind of goes in my head because I think of product and addition kind of going together, and I think of division and subtraction going together. So to me, that helps me remember that. So low d high minus, high means write the top function down, d low, take the derivative of the bottom over the bottom squared. And guys, again, for right now, we're just going to leave that like that. Later, we will have to multiply things through and factor out and cancel and all of that. But for right now, for an introduction, we're not going to do that. Okay? All right. So, that's pretty easy. And I just want to point out, and I'm looking at all these problems. In part C, I might divide everybody through by x and just do it like that. Like sometimes you have to choose what is faster or easier for me. And I think it would be easier just for me personally. If I went through and divided everybody by x, then I'd have x squared over 2 minus 2x plus 2 minus 1 over x. And that to me might be a little easier to take the derivative of. So just because it's a quotient doesn't mean you can't use algebra skills to make it look different before you begin. Because that might be a little bit easier for you to take. It wouldn't be so big, and it would probably simplify real easily. And that would be y prime would equal, I think I did that. Let me make sure I divided right. The 2 would be on the bottom, yeah, x squared on the top. 2 would be on the top, I did keep my minus, and that's an x. 2, yes, I did that right. 2, 1, 2, 0. Okay, so if I took the derivative of that, that would be 2, take away a power, and that would cancel. So that would just be x minus 2, and then that would be, I'm going to write this plus 0 for emphasis so you'll know I didn't forget little 2. And then remember, I have to think about this as minus x to the negative 1, so that would be positive x to the negative 2. So I'd end up with a pretty simple derivative that would not look that way if I tried to do that initial quotient rule, which is x minus 2 plus x to the negative 2. Okay. So if it's something very simple like in part A, then you'll want to do that low d high minus high d low over low squared. If it's something where the power is simple on the bottom and very complex on the top, you might just do long division quickly and make it simple and then do it, okay? Let's do another real, we need to do this quotient rule. Let's do part B. I'm going to try to move the screen over just a little bit. Sometimes that doesn't work with this new program I have. Sorry, it's a little shaky. I'm getting used to it. All right, let me get rid of that little line right there. No, I just want that. It is not going to go away. Who cares? All right, I need a line anyway, right? Okay, so here I go. You ready? I'm going to take the derivative. Low, right? Low down. D high. Derivative of the top. Write the bottom one down, derivative of the top. Minus, write the top down, just like it is. Write the function down, the whole thing. And then the derivative of the bottom. Oh, and I'm going to have to go and make some room. I didn't really plan for that very well. Make that a little smaller. Okay, so let me do this. 5x plus 3. And then the derivative is 2x plus 4 over the bottom squared. And that's one of the biggest things that people forget is that, you know, the product doesn't have a denominator, but the quotient does, and they'll forget it. So the reason I am just saying equals this is because this says the derivative of this, and I'm saying is that. That's why you don't need an extra symbol. That's why they write those questions with d, because that's like dy. This whole thing is y, dx. So the derivative is bottom, derivative of the top, minus top, derivative of the bottom, over the bottom squared. I always say you start down low on the dance floor. Haha, just kidding. All right, so that is the end of the product rule and the quotient rule. In the next video, we'll talk about e to the x and natural log and how to incorporate that in these different rules.